We need to find the value of this surface integral taken over the portion of this surface for which z is greater than or equal to 0. This is your surface integral when f vector is given to us. If you notice that if I put z equal to 0 on this surface, I will be getting the equation of the circle. So we will work on that equation of circle and evaluate this surface integral, right? So this is the surface given to us with z greater than or equal to 0, and we get the equation of the circle by putting z equal to 0 in this surface. So the equation of the surface meets the plane z equal to 0 in the circle given by, just put z equal to 0 over here, we are getting the circle, that is x square plus y square minus 2ax equal to 0. For z equal to 0, making the perfect square, this is x minus a whole square plus y minus 0 whole square, and for this I have to add on the right hand side a square for z equal to 0. Let's take S1 to be the plane region which is bounded by this circle. And what about the unit vector which is normal to the plane z equal to 0? Z equal to 0 plane means xy plane, and the unit vector normal to this xy plane is along the z axis. So we take this n vector to be k vector. Yes? Okay. So let's write this. Since a unit vector normal to the plane z equal to 0 is along z axis, that is k vector, so therefore we take n vector to be equal to k vector. Because we need to evaluate this integral, so we need curl of f vector. Yes, and this is our f vector. So finding the curl of f vector, just write here I vector, j vector, k vector, then curl by curl x, curl by curl y, and curl by curl z. Writing the first component of f vector, that is y square plus z square minus x square. Writing the second component, that is z square plus x square minus y square. And then writing the third component, that is x square plus y square minus z square. Let's solve this. So this is I vector. Partial derivative of this with respect to y, it is 2y, minus partial derivative of this with respect to z, it is 2z, minus j vector. Partial derivative of this with respect to x, it is 2x, minus partial derivative of this with respect to z, it is 2z, plus k vector. Partial derivative of this with respect to x, it is 2x, minus partial derivative of this with respect to y, it is 2y. And now we need to take its dot product with n vector. And taking its dot product with n vector is k vector here from this. So dot product of I with k vector is 0, dot product of j with k vector is 0, dot product of k vector with k vector is 1. So this is 2 times x minus y. Now we need to evaluate this integral. So thus, the surface integral of curl of f vector dot product with dA vector, this is further equal to the surface integral over, let me take S1 here, curl of f vector dot product with, okay, what is dA? dA is the vector area of the subsurface, right? So this is equal to n vector ds. ds is the magnitude of the area of the subsurface. dA is the vector area of the subsurface. Very fine? Okay. So I'm writing here n vector ds. Let's evaluate this further. So this is equal to the surface integral. Okay, what is curl of f vector dot product with n vector? We have found this to be twice of x minus y. So this is twice of x minus y ds. Please mark this as 1. Now to solve this integral, I need to change this to the polar form. And for that, we always put x equal to r cos of theta and y equal to r sin of theta. That is very fine. But I'm also having the equation of the circle from here. From here I'm having the equation of the circle x minus a whole square plus y square equal to a square, right? Because I want to use this equation, therefore I'm going to put x minus a to be equal to r cos theta. That doesn't matter, right? And y as it is r sin theta. Is it okay? Fine? Okay. So let's write this on the next page. So just put x minus a to be equal to r cos of theta and y to be equal to r sin of theta. ds will be dx dy and dx dy will be changed into r d theta. Now I need to find the limits of r. For this, let me square both these equations and then after squaring I will add these equations. So squaring 1, so this is x minus a whole square equal to r square cos square theta, and squaring both sides of this we get y square equal to r square sin square theta. Now I am going to add these two. So on adding we get x minus a whole square plus y square equal to, if I take r square common, I get in the bracket cos square theta plus sin square theta, which is equal to 1. So that means I am getting this to be r square. And from the equation of the circle, this is equal to a square. Yes. So this is a square. Reason: x minus a whole square plus y square is equal to a square. So from here we get r equal to a. Theta varies from 0 to 2 pi and r will vary from 0 to a. So let's put all these details to this surface integral. This we have found to be twice of x minus y. ds becomes dx dy and this is equal to double integration twice of, putting x equal to a plus r cos theta. This is a plus r cos theta minus y is r sin theta. X is a plus r cos theta. dx dy is r d theta. Because I need to integrate this first with respect to theta, so I'm writing here theta and then I will write r. Because we need to integrate first with respect to theta, so writing the limits for theta to be 0 to 2 pi and then writing the limits for r, that is from 0 to a. And now integrating first with respect to theta, I'm taking 2 outside. This is dr. Okay, so this is a theta plus integration of cos theta is sin theta. So this is r sin of theta minus integration of sin theta is minus cos theta, right? So managing the sign, and this becomes plus r cos theta. And the limits from 0 to 2 pi. When putting the upper limit we get, this is 2 pi a, this becomes 0 and this becomes r because cos of 2 pi is 1. So we are getting 2 pi a plus r when putting the upper limit. So this is twice of from 0 to a. So this is 2 pi a plus r when putting the upper limit minus, when putting the lower limit we get this to be 0, this to be 0 and this to be r because cos of 0 is 1. So this is r, sorry, this is r dr, right? So this is r dr, So these two cancelled out. This is twice of from 0 to a, 2 pi a r dr. Now integrating with respect to r we get, taking 2 pi a outside. So this is 4 pi a and integrating with respect to r, this is r square divided by 2 and the limits from 0 to a. Putting the upper limit we get a square divided by 2 minus, when putting the lower limit we get this to be 0. So this is equal to 2 pi a cube, which is the required answer for the surface integral. So this is 2 pi a cube. Okay, thank you. Stay blessed.